Hello class, hope everyone is fine. Today we are going to continue from where we left last time, and I'm introducing you to organic chemistry. We have organic chemistry 1 and organic chemistry 2. So for today I'm going to run organic chemistry 1, and in this organic chemistry we are going to study hydrocarbons. I'm going to explain in a while what a hydrocarbon is. We find that animals, including ourselves, are made of carbon. They are made of carbon. That's why carbon-14 dating is one of the methods used in determining the age of species. Now, so organic chemistry is simply a branch of chemistry that is going to study about carbon compounds present in both living and non-living organisms. And this non-living will mean dead organisms. At the same time, we have man-made, or we call them synthetic, substances which also contain carbon. For example, the plastic contain a type of carbon that we call polyphenol chloride. So we want to study more them. Now, as I said that compounds that make up living things made of carbon, whether living or dead. And one possibility why carbon is this, we're going to study it and its structure. We find that it is tetravalent. In other words, carbon has got 4 valence electrons. So it needs to combine with other 4 electrons in order to form bonds. And like in your structure and bonding, these are covalent bonds. That's why we talk about tetravalent. Covalent bond, so that if you have an XO, you're having something like that. So that's something we're going to describe here. It's able to form covalent bonds with itself and many metals like non-metals like hydrogen, nitrogen, oxygen, halogens, form a variety of compounds. It's because it uses all its valence electron, that's one. Uses all its valence electron in bonding, form strong covalent bond. And it can also covalently bond to form single bonds, like this one. And we can also have it forming double bonds, in the case of substance called alkenes. So it can also form triple bonds in the case of alkynes. So it can form a single bond like in CC, double bond like in CC, but a double bond, and a triple bond across it. So we are going to see all this, so don't worry about that. That reason, carbon atoms can be covalently bonded to form a very long chain, which we are going to see. And this long chain is called hydrocarbons. And this hydrocarbon, when we talk about hydrocarbon, we talk about the study of carbon and hydrogen. So hydrocarbon mainly involve carbon and hydrogen. Now, Hydrocarbon are a group of organic compounds containing or rather made up of hydrogen and carbon atoms only. Now, depending on the type of bond that is there, whether it is single, double, or triple, we are going to have 3 types of hydrocarbons. And these hydrocarbons are alkanes, alkenes, and alkynes. Alkanes, alkenes, and alkynes. So then we are going to also discuss about their substituents. Now alkanes are hydrocarbons. They are hydrocarbons or the organic compound with single bond between any 2 carbon atoms. So all the bonds in alkanes are single bonds. Now alkanes are made up, alkane, that's what alk is something I want you to notice. Alk. So this one is alkane. Your prefix alkene and alkyne. So this one is why. So these are all hydrocarbons, and we begin with alk, all of them. We have a prefix and a suffix. So the prefix is alk in all of them, but depending on the number of double bonds, so suffix take a different definition. So this one is why I put it this way. I'm going to explain the why so that it helps. Now, we have a general formula. I want you to be very careful because this topic is easy and the same time difficult. It is easy when you listen to what I have to say. It's difficult when you have to do your own thing. So we have just a general formula, Cn H2n plus 2. So all elements that have this formula, whereby n stands for the number of carbon atoms in a given hydrocarbon. The number of carbon atoms, and I'm going to show you how to use this formula here. Now, these are the hydrocarbons with general formula. That one, where n is the number of carbon atoms in a molecule. Now, the carbon atoms are linked by a single bond to each other and to the hydrogen atom. Now, so we have, going back here, first one is meth, then we have meth, then we have egg, then we have crop, then we have butte, then we have tent, we have eggs, then we have hept, then we have oct, then we have non, then we have death. Now, this is the earth part. Then alkane, the A-E, alkene, E, then alkyne. Now, when it comes the first one, this one will be methane, but this one doesn't have this, because they have at least 2 carbon atoms. So methane. The second one, this one will be ethane, ethene, ethyl. That one will be propane, propene, propyne. Butane, butene, butyne. Pentane, pentene, pentyne. Hexane, hexene, hexyne. Heptane, heptene, heptyne. Octane, Nunen, Nunin, Nunine. The Ken, the Kin, the Kai. Now once you've already learned about this prefix, then the suffix will just play a very interesting role. So you just have to, so this is for alkanes, this is for alkenes, and some for alkynes. But we'll come to that one later. Just show you. So coming here for this one, without this being alkane, we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, lunane, and decane. So the last part, if you realize that this last part is just the same, N, nothing. Now, we have certain type of formulas here. We have the general formula or molecular formula of a compound, which shows the number of each atom present making the compound. E.g. the cane has a general formula of C. Now, so I want to show you some of the molecular formula. Remember that we have CnH2 N plus 2. Now, methane has got one carbon. Methane has got one carbon. This is number 1, number 2, number 3, number 4, number 5. Has got 6, has got 7, has got 8, has got 9, has got 10. Now, which means the cane has got 10 carbon. Heptane has got 7 carbon. So, methane has got 1, butane, according to how I've arranged them, the number is increasing. Methane has got 1, ethane has got 2, propane 3, butane 4. Now, using this formula, suppose we want to write the general formula for butane. Butane has got 1, 2, 3, 4 carbon atoms. Now I said C, where we have N, butane has got 4. So which means where we have N, we put 4. Then H, 2 times N, and our N is 4. So 2 times 4 is 8. 8 plus 2, which is, so that means butane has got 4 carbon atoms and 10 hydrogen. Let's talk about maybe octane. Octane has got 8. Octane has got 8 carbon. So we begin with carbon, and how many are they? 8. We are ending with 8 plus 8. Want to find 2 times 8 plus 2. 2 times 8 will be 16 plus 2, 18. Let's say you want to talk about pentane. Pentane has got 5 of them. Pentane has got 5 of them. Now, pentane having 5 of them, we can say C5 which are there. Then H. 2 times 5 will be 10 plus 2, 12. Now that is how you use this formula to find. Now, even if you are told to find for lunane, you can find. If you are told to find for the cane, you can find. So let's find the last one, which is the cane. The cane, C10. The cane has got 10. H, which will be 10 times 2, which will be 20 plus 2. Now this is what we call the general formula, general or molecular formula. So we are going to stop there for today. So the next time we are going to pick from here and we see what else we can do with the information there.